Hello everyone, this is Dr. K. Abdul Wasi, Assistant Professor of Chemistry, C. Abdul Hakim College, Melvishar. In this video session, we will see a brief introduction about polymers. As we may know, around 50 years ago, when people goes out to buy provisions, they need to carry vessels or cotton bags. But nowadays, due to the applications of polymer, everything is available neatly packed in a plastic material which is also a polymer. Overall, polymeric industry is worth more than $1 trillion. The enormous success of polymeric industry is because of its unique properties. Due to its exceptional properties, polymer can be converted into strong, solid articles, flexible rubber-like materials, soft foams, smooth fibers. Similarly, it can also be used to bond objects, seal joints, and similarly can make bulletproof polycarbonate shields which can have the transparency of glass and the strength of steel. Hence, polymers have become an integral part of human life. In our daily routine, we use polymers in the form of toothbrush, sandals, toys, PET bottles, plastic vessels, spectacles, paints, car windshield, and so on. Not only in this sector, due to the various properties of polymer such as biodegradability, biocompatibility, and mechanical property, it is also used in biomedical field in the form of capsules, surgical items, bone cement, heart valve, cartilage, scaffolds, joints, artificial skin, implants, blood vessels, yarn for surgery, and so many other forms. By the definition of polymers, it is a Greek word in which poly means many and mer means parts. So, polymer means many parts which are joined together to form a polymer, large macromolecule which is a polymer. Hence, polymers are also called as macromolecule. Now, the question is how polymers are formed. Polymers polymers are formed by the process of polymerization in which smaller monomers are combined to form a bigger macromolecule called polymer. Polymers are formed by the covalent bonding of large number of repeating units or monomers. Repeating units are also called as monomers. In this slide, we will see what are monomers. Monomers are simpler and smaller molecules of similar or different types which react with each other to form a polymer. The monomers should have a functionality of at least 2. This is the condition in which monomers should obey. The functionality depends on the number of bonding sites or reactive sites or functional group present in a monomer. Some monomers do not contain any reactive functional group, but the presence of a double bond or triple bond in the monomer induces polyfunctionality. Likewise, in some monomer, presence of easily replaceable hydrogen atom imparts its functionality. Now you can see in this slide some of the examples of widely used industrial monomers. From ethylene, by polymerizing ethylene, we can have polyethylene. Similarly, by polymerizing vinyl chloride, we can have polyvinyl chloride, which is used as pipes. Styrene can be used to form rubberic material by combining two molecules of styrene. Then we can have polystyrene. Similarly, tetrafluoroethylene can be polymerized to form a polymer which have high excellent anti-flammable capacity, which can be used in pans. Now in this slide, we by using a graphical image, we can easily understand the difference between monomer and polymer. For example, if we consider the whole first train as polymer, then the each compartment or bogie is the monomer. So you can say there are 8 bogies in the first train. So there are 8 monomers. And the entire train, which is made up of many monomers, are called polymers. Polymeric Polymer is a generic name given to a vast number of materials. The material can exist in countless forms and can have different structural, physical properties, chemical properties, mechanical behavior, and thermal properties. Depend upon those properties, we can classify polymer into few types. The first type of classification can be seen in this slide. That is the classification of polymers based on source. Based on source, we can classify polymers into natural polymers and synthetic polymers. Those polymers isolated from natural material are called natural polymers. For example, cotton, silk, wool, rubber, cellophane, etc. These are some of the examples of natural polymers. Similarly, the second type of polymers in this classification is synthetic polymers. This is also called as man-made polymers because it is prepared in the laboratories. Polymer synthesized using chemical process from low molecular weight compounds, that is monomers, are called as synthetic polymers. Some of the examples of synthetic polymers are polyethylene, polyvinyl chloride, polystyrene, etc. Now, in this slide, we will see the second type of classification based on thermal response. Based on thermal response, we can classify polymer into two types. The first one is thermoplastic polymers and the second one is thermosetting polymers. In the case of thermoplastic polymers, some polymers soften on heating and can be converted into any shape that they can retain on cooling. That is, the process of heating, reshaping, and cooling can be done several times. Such polymers that soften on heating and stiffen on cooling are called as thermoplastic polymers. Some of the examples of thermoplastic polymers are polyethylene, polyvinyl chloride, polypropylene. In this case of thermosetting polymers, some polymers undergo chemical change on heating and convert themselves into a insoluble mass which cannot be reshaped. So it is a irreversible polymers. Polymers which become insoluble and infusible mass on heating is called as thermosetting polymers. These types of examples of these types of polymers are polyurethane, epoxy, unsaturated polyesters, etc. In this slide, we will see the another classification of polymers based on application. Based on application, we can classify polymer into four types, that is plastics, elastomers, fibers, and resin. In the case of plastic, if a polymer is shaped into a hard and tough utility articles by the application of heat and pressure, it is called as plastic. Some of the monomers used to make plastics are styrene, vinyl chloride, methyl methacrylate, etc. In the picture, you can easily see the image of polyvinyl chloride. The second classification is based on elasticity, that is elastomer. When vulcanized into rubbery products exhibiting good strength and elongation, polymers are used as elastomers. Now, what is meant by vulcanization? Vulcanization is a chemical process for cross-linking the rubber or rubberic material to have a durable properties. By using sulfur or any other material, we can cross-link the monomers. So, thus this type of polymer shows elasticity property. Some of the typical examples of this type of polymers are natural rubber, synthetic rubber, silicone rubber. In the second picture, you can find the images of rubber. Similarly, that type of classification is based on filament, that is its length, which is called as fibers. If a polymer is drawn into a long filament-like material whose length is at least 100 times its diameter, polymers are said to have been converted into fiber. Examples of this are nylon or antirylene. Final type of this classification is resins. Polymers used as adhesive material, potting compounds, sealants, etc. are some of the examples of resins, which is in a liquid form or in a solid form. Commercially available epoxy adhesives are polysulfide sealants are some of the widely used resins. In this slide, we see another type of classification based on nature of monomer. Nature of monomer, we can classify polymer into two types, organic polymer and inorganic polymer. For example, if a polymer whose backbone chain is essentially made up of carbon atom only, then it is called as organic polymer. However, the attached the atom attached to the side valencies of the backbone chain atoms are hydrogen, oxygen, and nitrogen. The longest horizontal line is the backbone chain. You can see it is the one of the examples of organic polymer, that is polyethylene co-styrene. The majority of synthetic polymers or man-made polymers are made from organic polymers. The second type of classification in this type is inorganic polymers. The molecules of inorganic polymers, on the other hand, generally contain no carbon atom in their backbone chain. Examples of these types are glass and silicone rubber. You can see the example of polysiloxane. It is a inorganic polymer in which the backbone chain is made up of silicon and oxygen. It does not contain any carbon atom. In this slide, we can see the classification of polymers based on repeating units. That is, in a chain, based on repeating unit, we can classify polymer as homopolymers or copolymers. If the polymer is made up of same, or you can say only one type of monomer, then the polymer is called as homopolymer. The monomer can combine with each other to form a large molecule in a linear, branched, or cross-linked fashion. For example, styrene is polymerized to have polystyrene. In this polymer, the monomer are only one type, that is styrene. Similarly, in the second example, ethylene is polymerized to form polyethylene, polyethylene or polyethylene, in which the monomer is only ethylene. Based on functionality, the homopolymer can be classified into three types. As you know that functionality is the number of reactive functional groups or double bond or triple bond present in a monomer. If a monomer is having only two functionality, then it can form linear polymers. That is, monomeric unit joined in the form of long straight chains are called linear polymers. Such polymers have high densities, high tensile strength, and high melting point. Examples of these polymers are polyethylene, nylons, and polyester. In the type of branched polymer, these are mainly linear in nature but also possess some branches along the main chain. They have lower tensile strength and low melting point compared to linear polymers. They have low tensile strength and low melting point. Examples of these branch polymers are low density polyethylene, amylopectin, and glycogen. Similarly, that type of polymer in this type is cross-linked polymer. It is a bifunctional or trifunctional monomer. That is, if a monomer is having more than two or more than three reactive functional sites, then it can form cross-linked polymer. It is also called as three-dimensional polymer. Three-dimensional polymers are hard, rigid, and brittle in nature. Similarly, if the polymer chain is having more than one type of monomer, or you can say different type of monomer or repeating unit, then that type of polymer is called as copolymer. Depending on the arrangement of the types of monomers in a polymeric chain, we can classify it into random copolymer, alternate copolymer, black copolymer, as well as graft copolymer. Here you can see the examples of butadiene and styrene, which is polymerized to form polystyrene butadiene polymer. Here in the polymer, we have used two types of monomer. In the earlier type, we have seen only one type of monomer which can be polymerized to form a polymer. Now, in this example, we have used two types of monomer. So it is called as copolymers. Uh, Due to copolymers, based on structure or you can say chain type, we can classify copolymer into four subtypes. The first one is random copolymer, alternating copolymer, block copolymer, and graft copolymer. In the random copolymer, The monomeric units are arranged in a random manner. You can see the image. The first one is the examples of random copolymer. In the polymer chain, you can see the orange color bubbles or balls indicate the one type of monomer, and the silver color bubbles indicate the another type of monomer. And in that chain, you can see orange bubbles are randomly arranged. So it is a random copolymer. In the second type of copolymer, that is called as alternating copolymer. In this type, two monomers are arranged in a alternate fashion. Two monomers are arranged in a alternate fashion, since it is called as alternating copolymers. In the third type, block copolymers. In this type of copolymers, a few blocks of one monomer is separated by a few blocks of another monomer or sequence of another monomer. It is the third type, which is called as black copolymers. The fourth one is graft copolymer. These types of copolymers are also called as branched molecules, where the main chain is made entirely of one monomer while the branch chain is made of another monomer. So these are the some of the examples of copolymer based on monomeric attachment or different polymer chain.